Hi kids, we'll be going into this paper discussion. You can look at the first question. The first question says, figure shows the circuit consisting of an inductor and resistors connected with the cell. All ammeters are ideal and the switch was closed at t equals to 0. Choose the correct statements. They are asking, look at the fourth option in steady state, this ammeter reading. So in steady state, this is going to behave like short circuit. You can find the equivalent resistance 2R and R parallel, that is in series with R, and you can find the current. That won't be matching with this option anyway. Now reading of ammeter A1 is the summation of these two readings. That's obvious because if this current is I2, this current is I3, then I3 plus I2 is nothing but I1. Now if you want to find reading in A2 and A3, that you can see it depends on the time. That depends on the time. So I am solving it using KVL. Probably we can find some bypassing the integration also. Yeah, anyway, so if I am calling this current is I2 and this current is I3, this current will be I2 plus I3. Now if I write loop equation for this loop, then I will be getting this equation. If I write loop equation for this loop, then I will be getting this equation. Now there are two variables in the equations which are I2 and I3. So what I will be doing is I will be rewriting this equation and I will be rewriting this equation. And I will be eliminating I2 because that is easy to eliminate because di3 by dt is there, but di2 by dt is never there. So I am eliminating I2, then I will be getting an equation in I3. Now I can integrate it and solve it, or what I am doing is I have seen this kind of equation before, so I can visualize it's this kind of circuit where 2L is there and 5R is there and current I3 is flowing. So time constant is going to be 2L by 5R. Then I can write it like it is current growth. It is going to be this format. Maximum current is E by 5R into 1 minus E power minus t by tau. Tau is this much. That is current in A3. Now if I want to find current in A2, then I know this equation. So if I know I3, I can substitute it back and I can get I2. Right? I can substitute it back and I can get I2. The ground state and first excited state energies of hydrogen atom are minus 13.6 and minus 3.4 respectively. If the potential energy in ground state, those values they don't have to give, we already know. If the potential energy in ground state, see that those are the values when you have taken the potential energy at infinity is to be 0. Now if you take potential energy at the ground state to be 0, then what are the corresponding values? Okay, so this works like gravitation only because force is inverse square nature. So everything goes by the same way. Generally potential energy will be twice of total energy magnitude wise, but with a negative symbol, right? So kinetic total energy was minus 13.6. Yeah, magnitude wise it should be negative. Sign wise it should be negative, magnitude wise it should be twice. That you people know already. So if the total energy is minus 13.6, then potential energy will be minus 27.2. When? By assuming potential energy at infinity to be 0. So kinetic energy is going to be magnitude wise exactly total energy, that is 13.6. So this yellow thing was the energy when I consider potential energy at infinity to be 0. Now this green thing is the energy for excited state when potential energy at infinity was 0. Now what they were saying, assume we need to take the reference in such a way that potential energy in ground state is 0. So if I want to make the potential energy at ground state to be 0, how much I should add potential energy to every point? It has to be 27.2. So only potential difference matters. So if I am making this guy 0, I am adding 27.2. So I should add 27.2 to every guy. So potential energy here is minus 6.8 when I have taken reference at infinity to be 0. Now I should be adding 27.2. So yes, that's all. Now first option, potential energy in the first excited state. Potential energy in the first excited state is going to be this minus this, which is option A. Total energy in the first excited state. So that is this energy plus this energy. So that is going to be option B is also correct. Then option C, kinetic energy in the first excited state. Kinetic energy doesn't depend on this changing reference of potential. Kinetic energy is absolute quantity. So kinetic energy will be remaining same. Total energy in the ground state, it will become plus 13.6. And going to this question I have already discussed it in old revision class, and apart from that it came in one of your recent exams. So I have just attached that corresponding PDF. You can go through that. This was the question what I have taken in revision class, and yeah, I think similar question came in. Okay, fine. Consider two solid spherical asteroid of uniform density of mass m and radius r. In one asteroid, a tunnel of very small size of depth r is bored to the center, and in another asteroid, a spherical cavity of radius r by 2 is made as shown in the figure. Now, identical particles of mass m are dropped into cavities of both asteroids from topmost point P. The force experienced by particles are F1 and F2 respectively in the cavities of asteroid 1 and 2 when they are at a distance x from the center. Now, the time taken by the particles was also given. See, here it is going to perform SHM, here it is going to be uniform field. That you should be aware of in order to solve this question. So, once you know it is going to be SHM form, like when it is at a distance x, the force is going to be this much. So, once you see forces of kx form, then it is going to perform SHM. So, then time period will be 2 pi into root of 2 pi by omega thing, right? You can look at this one like SHM, then the time period is going to be this much, but the time period is for the total time. Like if there was a full tunnel, then the time taken to go from here to here, plus here to here, plus here to here, plus here to here. That time is this much, but we need only 1/4 of the time. Now, what about this? Field is going to be uniform. This is a very known question in electrostatics. So, the similar way it works in gravitation also, because force is inversely proportional to r square nature. So, field is going to be uniform here. So, the easy way of calculating is calculating at the center of the cavity, because at the center of the cavity, field due to bigger one is this much, field due to smaller one is 0. So, this is uniform field. Now, what they were asking? They were asking F1 by F2. So, if you take the ratio, then you will get option A, correct. Then ratio of time periods. Now, this time period is this much. Now, this is uniform acceleration. So, time taken will be square root of 2h by A. Square root of 2h by A. This is r. So, square root of 2r by A. Acceleration is from here you can find and you can substitute. Then you can take the ratio. That's a straightforward. But you should be knowing it is going to perform SHM here and it is going to be uniform accelerated motion here. 4 identical conducting plates of area A each are connected in the circuit. The gap D between the adjacent plates is same. Initial charge on each plate is 0. Select the correct statements. So, battery is connected here. I will be assuming this potential is 0, this potential is V. So, other potential is left. So, I am assuming this is X. So, this potential is also X. I can redraw the figure by putting 3 potentials 0, V and X. This capacitor is between, see, outside charges are going to be 0 because battery will be giving effectively 0 charge. So, outside charges will be half of the total charge, which is 0. Now, there is one capacitor plate, 1, 1. So, I mean, there are totally 3 capacitors. This is between 0 and V. This is between V and X. This is between X and 0. So, these two are in series, C by 2 and C. In parallel, 3C by 2. Equivalent capacitance is 3C by 2, where C is epsilon A by D. Now, sum of charges on plate 1 and plate 4. These are isolated plates. So, sum of the charges on it should be 0. So, option B is also correct. Now, what is the charge on this capacitor? This potential difference is V. So, charge on this capacitor is CV. So, that is this capacitor. Charge on this capacitor is CV. So, this will be plus CV, this will be minus CV. But what is the equivalent capacitance? Equivalent capacitance is, okay, or else I can say what is this capacitance? This capacitance is C by 2. So, charge on this guy is plus CV by 2, minus CV by 2, plus CV by 2, minus CV by 2. This is between V and X. The thing between V and X, the charge is CV by 2. So, this will be plus CV by 2, this will be minus CV by 2, plus CV by 2, minus CV by 2. Now, from here, surface charge on the right side of plate 2. Right side of plate 2, that is plus CV. Plus CV, it is not minus CV. They gave minus CV. The charge on the left side of plate 2, that is plus CV by 2, it is not 0. Right? And that question was already taken in, I think, revision class, old revision class. Train is moving with constant speed along a circular track. If the length of the train is 1/4 of the length of the circular track, then which of the following are correct? I think this was there in PYQ, I think. Train is moving with a constant speed. The length of the train is 1/4. The length of the train is 1/4. Now, frequency observed by the passenger who is sitting somewhere. See, I don't have to talk exactly middle. I can show you like no matter which guy I am going to take, the relative velocity is going to be 0. Now, if I take any random point, you can see this guy's velocity is going to be this way. This guy's velocity is going to be this way. Now along the line joining, if I take this angle as theta, this will be 90 minus theta. Now this length and this length are same. So if this is 90 minus theta, this will be 90 minus theta. If this is 90 minus theta, this is 90, so this will be theta. So velocity along this direction is v cos theta, velocity along this direction is v cos theta. Relative velocity along the line joining is 0. So apparent frequency will be same as actual frequency. So option C will be correct, option A and B will be wrong. But what about the wavelength? Wavelength depends only on the source movement. Source is going away, so the distance between two successive compressions is going to become more, which I try to visualize it like kinematics. So I'll visualize there is some guy moving in this direction by throwing the balls, right? So the distance between two consecutive balls is going to increase, wavelength is going to increase. And in the next question, a particle of mass m is moving in xy horizontal plane. It is moving in xy horizontal plane, strikes the end of the vertical rod at an angle 37 degrees with the y-axis. A rod of mass m and length L is free to rotate about the hinge along y-axis. If the particle strikes with speed u and sticks to it, then choose the correct statements. So basically, this is the rod, and the rod can translate via this way. The rod can translate, but it can rotate this way. Now this is what is happening. So there is some mass coming and hitting. Now what I will be doing is I will be resolving this momentum into two components. One is this momentum, one is this momentum. Because of hitting from this side, this entire thing will be moving this way. Because of it hitting from this side, it will be rotating. So the entire thing will be translating this way and it will be rotating this way. So what can I do is I will be resolving the initial momentum, and due to hitting in this direction, this entire thing will be translating this way. So I will be doing momentum conservation. When I do momentum conservation, all the things are moving in the same direction. Alright, so I can do initial momentum is 4m u by 5, final momentum is net mass is 2m into final velocity. So that will be velocity is u by 5, that is not 2m u by 5, that is 2u by 5. This is velocity 4u by 5, 3u by 5. So velocity is going to become 2u by 5 by momentum conservation. So initial velocity with which it is hitting in this direction is 4u by 5. After hitting and sticking, this entire thing will be moving with 2u by 5. Now that is by momentum conservation. Now I can't do angular momentum conservation about this point, but I can do angular momentum conservation about this axis, because if net torque is 0 about some axis, then I can do conservation of angular momentum about that axis. So about this axis, torque is going to be 0, so I can do conservation of angular momentum about that axis. What is the initial angular momentum about that axis? L into 3mu by 5. Now final angular momentum is going to be I into omega. L into 3mu by 5 initial angular momentum about y-axis, that equals to final angular momentum about y-axis, that is moment of inertia into omega. From there I will be getting L omega value. Oh, but what we need? We need velocity of the particle after I did option D first. Angular momentum will be considered about y-axis. Because torque along this axis is going to be 0. Now minimum, okay, I can go with the option, okay, A and B. Velocity of the particle after the impact. So it is going to go with, this entire thing is moving through 2u by 5. So this particle is having 2u by 5 in this direction, and it is rotating this way, so L omega in this direction. So that will give you option B. Is 2u by 5 in this direction along J, yes, and L omega is 9 by 20 in this direction, that is minus I. Yes, so option B will be correct, so option A will be wrong. Now once you know omega value, so what it should be doing with that omega, what should be the omega such that it will be performing circular motion. So what should be the least value of omega? It will perform circular motion. Whatever kinetic energy is there, that's sufficient to convert into potential energy. Whatever kinetic energy available due to rotation thing, half I omega square. If that can go as change in potential energy. This is change in potential energy of the rod. This is change in potential energy of the mass. So if the kinetic energy, rotational kinetic energy, if it can go as change in potential energy, then that's sufficient enough. Right? Omega value I just substituted from here, and I will be getting the required answer. The next question: a large flat sheet carries a, okay, anyway, they have given a lot of stuff. So basically, if the charge density is current per unit length is given, then you can find the magnetic field due to the sheet this way. Wave. Magnetic field in the wave is varying this way. So if magnetic field is varying this way, then you need to find what is the electric field and what is the intensity. Now, we know E bar cross B bar. E bar cross B bar is going to be in the direction of wave speed. So if you want to find direction, so if you want to find the electric field direction, it is B cap cross C cap. If you want to find magnetic field direction, it is C cap cross E cap. If you want to find wave direction, then it is E cap cross B cap. So you can go with that thing. So now in this case, we need to find what is the electric field direction. If I want to find the electric field direction, then that is going to be V cap cross C cap. Now according to the given question, magnetic field is in K cap direction. Magnetic field is in K cap direction and wave is propagating along plus I cap. Magnetic field is along K cap and wave is propagating along plus I cap. So electric field will be along J cap. So that will be matching with only option A. If you want to find magnitude, you can find the magnitude also, because electric field amplitude E equals to CB thing. That relation you can use. Now intensity. Intensity is given, so they are asking J value. So total intensity is going to be half epsilon naught E square into C or V square by 2 mu naught into C. Both are going to be the same thing. Now B, I mean maximum value. B's maximum value is this much. So when you substitute, that value is given as 570 in the question. It's only about solving from there, right? So in the next question, they were saying, yeah, there is some gas which is going from 1 to 2, 2 to, this is constant pressure process, constant volume process, this is adiabatic process, this is isothermal process. They are asking what is the efficiency of the cyclic process and variation of entropy with temperature. And I think with the given information, you can find what is the initial temperature. Anyway, I am calling it as T. So if this temperature is T, pressure is at constant pressure, volume is becoming twice. So temperature will become 2 times. At constant volume, pressure is becoming 2 times. So temperature is going to become 2 times. And this is adiabatic process. So I will be using TV power gamma minus 1 is constant or PV power gamma is constant. And I should find what are the values. What are the values of P4 and V4, because they said this final this is isothermal. So if this temperature is T, this temperature is also T. Now what is the heat given to the gas? NCPT. NCP delta T. Delta T is nothing but T. This is constant volume process. So heat given is NCV delta T. This is adiabatic, heat given is 0. This is isothermal. So heat given will be work done. nRT log V2 by V1. This is going to be positive value, this is going to be positive value because temperature is increasing, this is 0. Now this is going to be negative value because volume is reducing. Now if I want to find efficiency, that is work done by heat taken, that is heat taken is here and here. Now work done is nothing but, for a cyclic process, delta U is 0, so work done is nothing but delta Q. Delta Q is the total heat, that is heat taken by the gas and heat rejected by the gas. So if you can find this one and this one, that is heat in this case and heat in this case, and when you substitute, we'll be getting the answer. But I didn't do the calculation because I didn't calculate these values. And I think in the solution they have given that. I think you need to calculate this value using PV power gamma is constant thing. And variation of entropy with temperature. Now entropy is integral dq by t. Now if dq is 0, I mean this is change in entropy, So change in entropy is going to be 0. Entropy is going to remain constant. In which case in 3 to 4 in adiabatic it is going to be constant. Yes, fine. Temperature is reducing in the figure. Yes, that is okay. Now I think we don't have problem with this one also. 1 to 4, what is 1 to 4? Isothermal and dq is negative, so entropy is reducing. dq was negative, so entropy is reducing. Now 1 to 2 is constant pressure process, 2 to 3 is constant volume process. So if it is constant pressure process, dq is ncp dt. If it is constant volume process, it is ncv dt. So no matter what is the process, it will turn out to be something like nc dt form. So when you integrate, you will get nc log t by initial temperature. So this graph we need to plot, log t graph. Log t graph is going to be something like this. But C value is going to be different for this curve and C value is going to be different for this curve. So C values will be different. So you will be seeing like there is a difference in the curve. 3 identical uniform dominoes are arranged as shown in the diagram. The possible values of x such that the dominoes are in stable equilibrium is alpha like x, okay, x lies between some value. So I think their intention is, if this has to be in equilibrium, center of mass of, anyway, this can be in equilibrium if I hold this, because weight and normal, net force can be 0, net torque can be 0. If weight and normal pass through the same point, then net force can be 0, net torque can be 0. Now if I take this as my system, how can this be in equilibrium? Their center of mass is going to be, now center of mass of this domino is here, center of mass of this domino is here. Now their net center of mass, if it lies in this region, then normal reaction also can lie in that region and they can pass through the same point. So net force can be 0, net torque can be 0. See, if there are only two forces and if it has to be in equilibrium, that is translation plus rotational, they should be equal and opposite and they should be passing through the same point. If they don't pass through the same point, net torque won't be 0. So if mg is this way, normal can pass through this point because it is touching. But if the net weight, if the net center of mass is somewhere here, then it can't be in equilibrium because normal can only be in this region for this entire system. For this system, normal can be only in this region. So net center of mass should lie in this region, So I need to bother about the x coordinate. I have taken this as the origin. This is 10 millimeter, so this is 5 millimeter, and this is 52. So this half is going to be 26. This is 5. Out of 26, this is 5. So this will be 21. This is 21. So then now the net center of mass. So this is 21. Now out of 21, this is how much? This is 5 mm. So out of 21, if you neglect, okay. So we don't know where is this, so we don't have to bother about this 21. So if this is 0 and this is 21, so this guy's x coordinate was 0, this guy's x coordinate is 21. So the net center of mass will be at 10.5. Net center of mass will be at 10.5. Net center of mass will be at 10.5. So net center of mass of this thing will be at a distance 10.5 from here. So the extremes I can take it is, so if the center of mass can lie on this red line, then I can say this length is going to be 10.5. If the center of mass is lying on this red line, then I can say this distance is 10.5 and this is 10. So this is 0.5. So if the center of mass has to lie between these 2 points, then this distance has to be this distance should be lying from 0.5 to 10.5. 0.5 to 10.5. So but they said this is x. So this value should lie between 5.5 to 15.5. So I think that's the answer. A magnetic disc is moving on an air cushioned table above a metal sheet. Due to generated eddy currents, there is a retarding force exerted on the disc, which is, okay, you can read the question. I'll be showing the explanation and I'll be reading out the question. Magnetic disc is moving on, okay, moving above a sheet made of aluminum. The disc stops after covering a distance of 30 centimeter. So the only force, retarding force, is this thing, right? So retarding force equals to mass times of acceleration. Now you can see, you can write the same equation like this, you can write the same equation like this, or we could have done the integration thing also. But when you write it this way, it looks so easy. It looks like we have discovered some conservation law in this particular question. So there is some conservation law which we discovered in this particular question, that is mv bar plus kx bar is 0. So initial thing, if initial x coordinate, if I take it as 0, then initial this thing is mv naught, initial this thing is 0. Now that should be constant at any time. So when it stops, x value is 30 given in the question. So that k depends on what kind of material it is. So aluminum, you are sending it over aluminum, so that k value will be different. That retarding force will be depending on that material, aluminum or copper, right? So when it is aluminum, I am calling that constant as A. So this is the first equation. Now in the same way, when I talk about copper disc, copper sheet. When the sheet is made of copper, that disc is going to stop at 20 centimeter. So I can use the same conservation law and I can write this one. But there are many unknowns, so let us keep it that way. In the next case, it is traveling over copper sheet first, 15 centimeter. Then it is moving over aluminum. So it is traveling over copper first. So initial thing in the copper. When it started on the copper, x coordinate was 0 and mv0. This thing. That equals to, now when it ended on the copper, velocity was not 0. So let me call it as v1. So mv1 plus k, that's c. It is copper, right? So this constant I call it as c when it is over copper into 15. So by conservation law, initial this thing equals to final this thing when it is crossing the copper. Now once it crossed the copper, m into v1, and now I am, anyway, the difference in the x coordinate only matters. So I am taking x equals to 0 again in the aluminum thing. Now finally when it stops, velocity is 0. Now a into d. Or I don't have to take it 0, the difference is going to be a into d anyway. Now I need to solve this. So what I am doing is mv0 equals to a into 30, that equals to c into 20. Now that is same as, now yeah, this equation also I clubbed so that I can see it much easily. mv1 is a into d. So basically I have three equations. All are equal to mv0. mv0 equals to a into 30, mv0 equals to c into 20, mv0 equals to c into 15. So instead of calling mv0, I am calling it as some lambda for easy calculation. Now what I need to calculate, what is d. So I will be calculating a from here, a is lambda by 30, I will be calculating c from here, c is lambda by 20, and I will be substituting them back. I will calculate a from here, c from here, and I will substitute it back, then I will be getting the required answer d. Now d is the distance travelled in aluminum, and in the copper it is travelling 15, so total it's 22.5. Okay, this is a straightforward question. You need to find where there will be 70th maxima. So you will be calculating this length and this length, and you will be calculating this length and this length, and you will be finding the path difference. So path difference, this side is going to be dy y1 by d, where this is y1. Path difference this side is going to be dy y2 by d. So path difference totally from here to here is going to be dy y1 by d, dy y1 by d1 plus dy y2 by d2. So total path difference, if it is equals to 70 lambda, then it is 70th bright fringe, and d value is same 10 mm, y1 value is 1 mm, and capital D value is 1 meter, and small d is 10 millimeter. This is milli, and this y value is n millimeter, and d value is 2 meter, and lambda value was given in the question. You just need to solve for it. I think that calculation was more or less like straightforward. This path difference is going to be dy by d. This path difference is going to be dy by d. Then the next question was just energy conservation. So the question goes like, a rocket is launched normal to the surface of the earth away from the sun along the line joining sun and earth. So away from the sun along the line joining sun and earth, and sun is 3 into 10 power 5 times heavier than the earth. If earth mass is m, then this is 3 into 10 power 5 m, and if earth radius is r, then the distance between them is 2.5 into 10 power 4 r was given in the question, and escape velocity of from earth's gravitational field is given. So with what velocity you should be throwing it so that it will escape. So potential energy between this and this is going to be this much, potential energy between sun and this is going to be this much. And see, I am not writing potential energy between sun and earth because it is not changing, it is remaining same. So this potential energy can change, this potential energy can change, and if I include the kinetic energy, if the total energy is going to be 0, then that guy can escape to infinity. That's the idea. So when you do the calculation, you will be ending up with this calculation. Here. Now root of gm bar is root of gm 2 gm by r is nothing but escape velocity from earth, which is given as 11.2 in the question, right? Similar question came in one of your exam recently. It's like a straightforward question. I mean, if you have seen that question before. You need to find pressure variation. So what you will be doing, you will be taking some element and you will be writing net force equals to 0. So the pressure force and the weight. So I am giving everything to math, or else when something is reducing, then I take modulus and stuff. So I am assuming pressure is increasing, though the answer will say whatever it is. So at a distance y, this small thickness is dy, so its weight is going to be this much. So when I make net force equals to 0, obviously you can see both are in the same direction for me, because this is going to be less. Anyway, when I make net force equals to 0, I will be getting some equation, but in this equation, T is varying as y, this is a function of y. Okay, sorry, density is also varying, so I am taking help of gas law and I can replace density in terms of pressure. Now I can see this is P, this is P. Actually, this is varying, this is varying, this is varying. Now I replaced density with pressure and temperature thing. So this is variable, this is variable, this is variable, this is variable, but T as a function of y is given. So there are two variables, y and P. So I will be separating P terms to one side, y terms to one side, and I will be integrating at y equals to 0. That is on the surface, they said pressure is P naught. At any y, we need to find what is the pressure. I will be integrating and substituting the limits. And I have attached the question from the last exam also, so you can go through that also. The next question goes like, the web of negligible weight has the shape as shown in the picture. The hexagons are regular and divide radial fibers into equal parts, L, 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 L. The ends of the web are fixed at the same height above the ground. At the beginning, web is not sagged. When spider moves towards the center of the web, web is getting sagged, so that it moves closer to the ground by distance h. So this is the web. When spider goes, then this is going to go down by distance h. So everything is going to go down by distance h. I mean, like not everything, the center. We need to find the Young's modulus, and they have given lot many stuff. Yeah, I didn't solve it exactly, but I will be explaining. Young's modulus is given by stress by strain. So you can write force equation like this, and you can see like this is like spring force K into delta L. So you can visualize like there are springs here, and spring constant is inversely proportional to length. If I assume this total thing as one spring, and the spring constant is K, this is going to be 4K. Sorry, K. Length is become okay. So okay, if I assume this spring constant is K, then this is going to be K by 4. Length is becoming 4 times, so spring constant is going to become 1/4. Now that's what they were doing. Now what is going to happen? Okay, so this is going to go into, or maybe I can say like, maybe you can take this thing. This point is here initially, so when spider goes here, it is going to go down by distance h. So yeah, I think, yeah, you can concentrate on only on this thing. So assume this wire is, the thread is like this. So this length is 4L, and when it goes down by distance h, that length is going to become square root of L square plus h square, which they have shown it here. So length is 4L, when it goes down by distance h, this length is going to become root of 4L square plus h square. Then force by that thread is going to be in this direction. Force by this thread will be in this direction, force by this thread will be in this direction. Now similarly, how many threads are there? 1, 2, 3, 4, 5, 6. But their horizontal components are going to get cancelled by symmetry, only their vertical components will survive. So we need to take 6 times of vertical component, Now how much will be the tension? Tension is going to be total spring constant times extension. Now what is extension? New length minus old length. This is the spring constant of the total thing, and this is the spring constant of one length L. So if this is small k, then this is capital K. So which is capital K is K by 4. Anyway, that is inversely proportional to that you can manage, no problem. So, and what is y? Y is this length is nothing but root of this square plus this square. I think cos alpha also you can find from the figure, and you can substitute. It's only about math. So finally you will be getting K value. So once you get K value, you can go back and you can substitute it here. K value is YA by L. And I think A value and L value were given, so you need to substitute you need to find the Y value, right? Hi kids, we'll be going into this paper discussion. You can look at the first question. The first question says, free uranium nuclei kept in a train emit alpha particles. When the train is stationary and uranium nucleus decays, a passenger measures that the separation between the alpha particle and the recoiling nucleus becomes x in time t after the decay. If a decay takes place when the train is moving at uniform speed, the distance between alpha particle and recoiling nucleus at a time t after the decay as measured by the passenger. See, in the first case also with respect to passenger, the nucleus will be at rest. In the second case also with respect to passenger, the nucleus will be at rest. So initial momentum of the nucleus is going to be 0. Now after alpha particle emission, recoil velocity. So basically if this nucleus is going to go in this direction, then alpha particle is going to go in this direction, both carrying equal momentum magnitude wise. So the same thing is going to happen in the second situation also. So if they are carrying equal momentum magnitude wise, then they will be having, so that's the same situation happening in the second case also. So whatever happens in the first case, the second case is going to look the same way for the guy in the train. Now from the ground frame, maybe velocities measured may be different, but the distance between the particles is going to remain same, right? So it will be x only. And two identical spherical masses are kept at some distance as shown. The potential energy when the mass m is taken from surface of one sphere to the other. Now this kind of question we have already done in some doubt section, where like with what speed you need to throw from surface of one planet to the other one, minimum speed needed so that the particle will reach from here to here. So when you do that, you will be trying to make it pass through this point. Now why we need to make it pass through this point? When you draw the potential energy curve, you will see potential energy is going to be maximum here. If the net force is 0, potential energy will be either maximum or minimum. In this case it is going to become maximum, that is called as potential barrier. So if you cross that potential barrier, then it will reach this planet. So whatever in this question, in our question they were saying when you are taking the particle from here to here, the potential energy will be increasing, then it will be decreasing. A uniform ring of mass m and radius a and sphere of mass m and radius a are released in free space. Consider only gravitational force between them. Find the acceleration of the ring at a given separation. See, the good thing about solid sphere or hollow sphere is for outside guys, it behaves like a point mass. So if I want to find what is the force on the ring, I can replace this with the point mass. Now instead of finding force on the ring by the point mass, I will find the force on the point mass because of the ring. That is going to be quite easy because you already know the well-known result. So force on the point mass because of the ring is going to be gmm by this distance square into cos cube theta. Now that is the force on the point mass. So that will be the force on the ring also magnitude wise. So that equals to mass of the ring into acceleration of the ring. A car drives along a road that has small depressions regularly spaced about 8 meters apart. When 4 passengers enter the car, it sinks down by 1.6 centimeter. At approximately what speed the car might travel, so the traveling in the vehicle will become very uncomfortable. See, they said 4 people are sitting inside, so weight is this much, so that is balanced by the spring force. So spring constant you will be getting. See, the essence of the question is, this is the natural frequency of the car, time period. So frequency you can say like inverse. So if the natural frequency of the car matches with the frequency of the road, like whatever that regular intervals thing, then the amplitude is going to become maximum, that is resonance condition. So the entire question is based on resonance condition. So the natural frequency, if it is equals to the forced frequency, then the amplitude is going to become maximum. So it is going to be uncomfortable. That's the idea of the question. 3 tuning forks in the audible range produce beats. B and C produce 7 beats. A and C produce 8 beats, and frequency of B is greater than that of A. So if I take C as my reference, then beats with A is 8 and B is 7. So let me say with A it is 8. So A can be lower than C, or A can be above C also. A can be more than C. But A can't be more than C according to given information because B and C produce 7 bits and B is higher also. So if A is above C, B is even above. Even above. So then the bit frequency between B and C will be more than A and C. So that option is eliminated. So A can't be more than C's frequency. Now if A is less than C's frequency, now B can have two kinds. One is like B can be between A and C. Between A and C. And B can be above C also. Now you can see bit frequency between B and C is 7, A and C is 8. Here also you can see between B and C it is 7, between A and C it is 8. So these are the two conditions possible. Now what will be the bit frequency between these two? That is this frequency minus this frequency, which is given in the question. That is 15. So from there you will be getting A's frequency. If you know A's frequency, if you add 6 you will get C's frequency, 8. If you add 8 you will get C's frequency. If you add 7 more you will be getting B's frequency. Now similarly here also you can get A's frequency, then add 1, then add 7, right? Okay, so I will be reading the question. Two identical thin homogeneous nichrome wires are mounted into the side non-conducting wall. So here the length of the wires is equal to height of the vessels. An ideal battery with voltage 46.2 is connected. The vessels are filled up to 50 centimeter and covered with light thin conductive piston. The pistons do not allow water to pass through them, have contact with the wires and can move without friction inside the vessels without leaving them, thanks to stoppers. An ammeter is connected to the piston using flexible wires. The length of the wires allow the pistons to move freely. The installation diagram is shown in the figure. When a non-conducting weight 1 kg is placed on small piston, what will happen? This one will go down, this one will go up. The ammeter shows 2.31. Now in the other case, if you put 3 kg here, then ammeter is going to show 2.1 ampere. We assume the connecting tube has negligible cross section and conductivity of water is very low. Water density is given. So initially the current is going to flow like this. That's the idea. So V equals to I into total resistance. This height is H0, this height is H0. Let me say resistance per unit length is lambda. So this resistance is lambda H0. This total resistance is 2 lambda H0. And this resistance is R. So V equals to I into R. Now there was another case where you have kept 1 kg here. I am calling it as M. So if you keep 1 kg, what will happen? This level will go down, this level will go up. Now by volume conservation, whatever volume is reduced here, the same amount of volume should be increased here. So if this goes down by Y, these areas are in the ratio 1:3. So if this length goes down by Y, this length will go up by Y by 3 because of volume conservation. A into Y is 3A into Y by 3. So the difference between the heights is going to be 4Y by 3. Now if the pressure here is P0, then pressure here is going to be P0 plus rho G into 4Y by 3. Pressure here is going to be P0 plus mg by A. So when you equate that, you will be getting what is the Y value. Now why I am doing this, I will explain. Now current is going to flow like this. Ammeter. So this resistance is going to become now less. How much resistance it is going to become? Lambda into H0 minus Y. This resistance is going to become more. How much it is? Lambda into H0 plus Y by 3. So total resistance is going to become lambda into 2H0 minus 2Y by 3. This length plus this length is going to be this much. So now V equals to IR when I use, I will be getting this equation. So basically I need to find Y. So that's the reason I have done this. Now in the similar way, there was another case. I didn't draw the figure, but it goes by the same way. You will be using V equals to IR and you will be finding that 2Y by 3. Now here assume it is different Y, but when you do the calculation, you will understand that it is going to be the same Y, magnitude wise. So now basically this equation I can modify. I can substitute the values of H0, I can substitute the value of 2Y by 3 and I can substitute the value of I1 and V0. When I substitute all those, I will be getting this one. Now similarly, in the other case also you can substitute all those values and you will get another equation. So basically you have got two equations. This is from one case, this is from other case, two equations, two unknowns. When you solve for those, you will be getting lambda is 20, resistance of the ammeter is 1. Resistance of the ammeter is 1. So from here, we will be getting option A. Now, but we can't get any other option. We need to get the option when in the natural case, in the normal case. So that is very first case. So in this case, we need to find what is the current. So V naught value is given. I naught value we need to calculate. Lambda value just now we calculated using solving equations. So when you substitute, you will be getting current in the first case is 2.2 ampere. So option B will be correct. Then they are asking maximum current and minimum current. See, when will maximum current happen? When resistance is least. When the resistance will be least. When the resistance will be least. If this level goes fully down and this level goes up. See, if this level goes fully down, this level won't go up by the same amount. It will be going up by only very small amount. So minimum resistance will happen when this liquid entirely goes to the other side. So if the minimum resistance, then it is going to be maximum current. Now for minimum current, resistance has to be maximum. When will that happen? When this goes down and this one goes up. So minimum current will happen when the resistance is maximum. Yes. So minimum current will happen when the resistance is maximum. When the resistance will be maximum? When this entire water will be going to this side. So by volume conservation, we will be getting that total length is 2. Now similarly, by volume conservation, we will be getting the total length is 0.5 plus 0.5 by 3 here. So it's a direct substitution. So it's better you draw the figure, then you understand like why it is 0.5 when it reduces, why it will be 1.5 increment here, because the areas are in the ratio 1:3, 1:3, right? So the next question, 3 tigers simultaneously begin to move along the horizontal surface with constant speeds. The velocity of the first tiger at any moment is directed towards the second, and the velocity of the second towards the third, and the velocity of the third towards the first. At the initial moment, tigers form a right angle triangle of lengths. This L, this is L, so this angle will be 45, 45, and this is root 2L. Consider the size of the tigers to be much smaller than L. The speed of the first tiger is V, and the speed of the second tiger is V2, and this is third tiger is V3, such that during the moment, the angles of the triangle formed by the tigers remain constant. So if I join line between B and C, A and B, B and C, and C and A, it is going to look 45 degrees and 90 degrees at any moment. This is what they were saying. Let us introduce the coordinate system as shown in the figure. The origin of coordinates coincides with the position of the first tiger. Then the time after which the tigers are going to meet. Now this one you can calculate easily, because you can see either at what rate this length is reducing, at what rate this length is reducing, at what rate this length is reducing. This length is reducing at a rate V only, because this velocity is perpendicular. So you can sit on one guy and you can observe this guy, and you can see at what rate this length is reducing. This length is reducing at a rate V. Now what about this length? This length, because of this movement, it is reducing at V2. Because of this movement, it will be reducing at V3 by root 2. So this length totally is reducing at a rate V2 plus V3 by root 2. Now what about this length? If this guy alone moves, then this length will be reducing at a rate V3. If this guy also moves, then it will be reducing at a rate V1 by root 2. So totally it will be reducing at a rate V3 plus V1 by root 2. So I can say the time taken for this reduction is L by V1. The time taken for this reduction is L by V2 plus V3 by root 2. The time taken for this reduction is root 2L by V3 plus V1 by root 2. Now all those three are equal and V1 is given as V. So V1 is given as V. So if I equate these two, I will be getting V3. Okay, I wrote the same thing again. If I equate these two, I will be getting, sorry, this has to be V3. It has to be V3. So I wrote the same equation, I equated these two, then I will be getting V3. Once I get V3, I can substitute it here. Then I can equate these two, then I will be getting V2. So basically this speed is V by 2 and this speed is V by root 2. Now I will be putting everything in the figure. So what are the answers we got? Option A, yes, everything. Time is L by V that we got from here. Now velocities of the other guys also we got. Now there is only one option left, that is coordinates of the point where the tigers will meet, Now notice this thing carefully, AB and BC, AB and BC are always perpendicular, because they said this triangle, I have put like triangle is reducing in size. Now I am not sure like whether it will be rotating also, but I can't fit the figure inside this triangle, so I have put it like this. So you can visualize like it is shrinking, but it may be rotating also. We can't, I'm not exactly sure about like how to draw the figure, but it's just a basic understanding. Triangle is going to look in a similar manner. Now suppose if we assume they are going to meet here, all those values you neglect. So suppose they are going to meet here. Now you notice this thing, this guy is going in this direction, this guy is going in this direction. So in the later moment maybe this triangle is going to look like this. So now this guy is going to go in this direction and this guy is going to go in this direction. Now if you notice, always they are moving perpendicular to each other, these two. Always they are moving. So just before meeting, just before colliding also, they will be moving perpendicular. So if this guy is moving in some direction, then this guy will be moving in the perpendicular direction to it. So if they are meeting, they are going to meet here such that this angle is going to be 90 degrees. So they will always be moving perpendicular. So just before meeting also, they will be perpendicular to each other. So while meeting, they will be perpendicular to each other. So yeah, there are many ways of doing it. They have given the other explanation also, you can look into that. So basically if you understand that if they are going to meet here, that angle is going to be 90 degrees and they will always be in the ratio 1:2, because their velocities are in the ratio 1:2. So this is V, this velocity is V by 2, this velocity is V. So they will be always in the ratio 1:2. Now you can see a right angle triangle here, and this length is this is 1:2 ratio. So I can get this angle tan theta is opposite by adjacent. From there I will be getting sin theta cos theta also. Now I need to find these coordinates. This length is L. So if I want to find this length, then it is L cos theta. Now if I want to find this coordinate, x coordinate, then it is L cos theta cos theta. If I want to find y coordinate, it is L cos theta sin theta. Right? Okay, in the next question, as shown in figure, a plano-convex lens has refractive index n and is placed in air. The radius of the lens of aperture is r. Take a point f on the principal optical axis, OF equals to f. When the parallel light is incident along the principal optical axis, all the light rays converge at point f. So we need to find what is the shape and what is the maximum value of aperture of the lens. So most of these kind of questions, we have seen already this kind of question in some of your exam here. So I am attaching that. So there you have already used Fermat's principle, now also you will be using Fermat's principle. So that is, if you take any random ray, the time taken by this guy to come here is same as the time taken by this guy to come here. So you can say either time taken is same or optical path length is same. So if this length is x, if that x coordinate is x, so that length is x, so optical path length is going to be n into x. And what about this length is x, so this will be f minus x. If you know this is f minus x, this is y, then you can find this length. So similarly, if I take another ray, then that length is going to be root of f square plus r square. So both optical path lengths should be same, or time taken is same. Time taken is same, meaning optical path length is same. Now I need to solve for it. I am taking the same equation. I am bringing this nx to the other side and I am squaring it. Then I am ending with some equation. So I am not sure about this equation. Probably you will be knowing like whether this is represents which of the conic section, hyperbola. Now focus has to be outside. So x coordinate, like whatever this x, whatever this y, when y equals to 0. Now this is the equation. This is the equation of this curve. So for this curve, when y is 0, that will be giving me this x coordinate, and that x coordinate has to be less than focus. So when y is 0, x coordinate has to be less than focus. So when I go with the critical condition, I can just substitute when y is 0, x is f. I am substituting when y is 0, x is f. Then Yeah, I didn't solve it here, but you can solve it. What I did probably was, okay, I just expanded. Thereafter, I'll be bringing this one to this side and I'll be squaring probably. So solving is in your hands. You will be getting the right answer. So solve it from there. You'll be getting this answer. So the next question goes like, an ice hemisphere of with a radius r and refractive index n lies on a warm flat table, melts slowly. The rate of heat transfer from the table to the ice is proportional to the area of contact between them. It is known that the ice hemisphere completely melts in time t0. Throughout the process, the laser beam is incident on the ice from above. The beam is vertically at a distance r by 2 from the axis of symmetry. Assume that the temperature of the ice and the surrounding is 0 degree, remains constant. The laser beam does not transfer energy to the ice. This is not giving energy, only this is giving energy. The melting water immediately flows off the table and ice does not move along the table. It is moving only vertically downwards. So we need to find the value of x0 where the laser beam will strike, and height at any height is going to reduce. So at any time we need to find this height, and at what time the laser beam will be hitting at r by 2. So it is coming at r by 2. So if it is undergoing refraction, it won't hit at r by 2. So basically it is not going to undergo refraction. They are asking when it won't undergo refraction. So basically when it melts such a way that the laser beam will be directly hitting. Anyway, we'll see step by step. We'll go with the first option first. Laser beam is coming here and this length is r by 2 given and this length is r. So you can find this length is root 3 r by 2 and you can get this angle is 30. If this angle is 30, this angle is 30. So angle of incidence is 30. When you use Snell's law, you will be getting angle of refraction. When you use Snell's law between, this is the normal. So if this is 30, then refracted ray, angle between normal and refracted ray is r, but this total angle is 30, so this will be 30 minus r. So Snell's law. Then I need to find what is x0. If this is x0, then this is going to be r by 2 minus x0, r by 2 minus x0. So I can take this triangle and I can take tan 30 minus r equals to this length opposite by adjacent. Opposite by adjacent. Now tan 30 minus r, I can expand it. Then I can tan a minus tan b by 1 plus tan a tan b. And I can substitute tan 30 value and tan r value from this one. Then I need to solve for it. When you solve, you will be getting x0 is this much. So you will be getting x0 value which matches with option A. If option A is correct, option B will be wrong. That I think, if you know if one of the options will be correct, then A will be correct than B, because you can see you can substitute n equals to 1. If you substitute n equals to 1, there won't be no refraction, there won't be any refraction, so the answer has to be r by 2. So you shouldn't be marking B. You shouldn't be marking B. You shouldn't get negative value by marking B, negative marks. Then the height of ice of Z at any time is given by. Now, at any time, let me say at any time, like it has melted and it came to this situation, you can visualize like some full imaginary sphere here, probably like this. So now the rate of heat flow is proportional to the, let me say this radius is r and this is z. So the rate of heat flow is proportional to this area. So that is pi r square. So proportional pi r square, so that constant let me call it as k. So what is the rate of heat flow? That is this thing. Now if heat flows, then what is happening? This ice is melting. So if continuously heat flows, continuously ice will be melting. If some heat flows, then this layer of ice will melt. That is dm into L. Now if I continuously send, then it will be continuously melting. So dm by dt into L, magnitude wise. But you can see mass is reducing. So dm by dt is going to be negative. That we will see anyway. Dm by dt. Now what is dm by dt? Dm by dt, this mass is going to be pi r square into dz. Pi r square into dz. So that mass is going to be, that rate of change of mass is going to be rho into pi r square into dz by dt. But dz by dt is like I am taking modulus value because I know this positive quantity, this has to be positive quantity. So as it is reducing, when you remove the modulus, I will be getting a negative sign. Now pi r square will be getting cancelled. Now you have to integrate that. Anyway, you can see it is linear relation. And I have two variables here. So I need two conditions, and I know initial condition. At t equals to 0, z value is r. At t equals to 0, z value is r. Now at t equals to t naught, z value is 0 they have given in the question. So substitute, then you have two equations, two unknowns. When you solve for C, you will get R. When you solve for M, you will be getting minus R by T naught. So substitute it back, substitute these values back, then you will be getting Z as a function of time. Z as a function of time. So option C is wrong because it is linear relation, they have given square. Now the time at which X will become R by 2. If X is R by 2, what is the value of Z? This becomes R by 2. See, now it will be melting such a way that when this becomes R by 2, then the beam will be hitting here. In all the other cases, beam will be hitting somewhere here after refraction. So when this becomes R by 2, that's about option D. So they are talking about this situation when this becomes R by 2. If this becomes R by 2, this is root 3 R by 2, this is R by 2. So I have drawn imaginary sphere here. Only this part is there actually. Now, if this is root 3 R by 2, this is R minus root 3 R by 2. So what is the value of Z? Z value is this much. We already know Z value is R into 1 minus T by T naught. So when will Z become this much? You can directly substitute and you can see that is going to be at time root 3 by 2 T naught. Going to the next question. A metallic rod of mass m and length L can slide without friction on two perpendicular wires. Entire arrangement is located in horizontal plane. The magnetic field of magnitude B exists perpendicular to this plane in the downward direction. The wire has negligible resistance compared to the rod. Initially, the rod is along one of the wires, so that one end of it is at the junction of the two wires. Show that the rod is given angular speed omega such that it will, okay, I think it is so that initial angular speed is omega such that it slides along it slides with two ends in contact with the two wires and just come to rest when it comes to this position. So it is going to go like this and stop here. The value of omega, we need to find the value of the omega. So initially this was the case, this velocity will be in this direction, so instantaneous axis will be here. Anyway, that doesn't matter much. So when it is going to this situation, now this is going to go this way, this is going to go this way, I can find instantaneous axis and I can find kinetic energy at this moment is half into I about this axis into omega square. I about this axis will turn out to be ml square by 3, that you can see it easily because moment of inertia, that is parallel axis theorem you will be using, about this axis plus parallel axis theorem. So about this axis plus parallel axis theorem will be same as about this axis and parallel axis theorem. So moment of inertia of rod about this end is ml square by 3, so about this point also ml square by 3. So kinetic energy at this moment is this much, where omega right now is this much. Now induced EMF you can find in many ways. You can find what is the rate of change of flux, or like I will be imagining some imaginary triangle and I will be visualizing this is a rotating rod, this is a rotating rod, and I will be subtracting those two EMFs because they will be in the opposite directions, V cross B and V cross B. So when I subtract those two EMFs, you can do in many ways. So if you don't know any other way, you just take the flux and find rate of change of flux, that will turn out to be this much. So EMF in this loop is this much and kinetic energy of the rod right now is this much. Now because of EMF, current will be flowing. Now if current is flowing, then there will be heat. So what is the rate at which heat is getting generated? That is V square by R. So this is square by R. Now at what expense this heat is coming? It is coming at the rate of kinetic energy loss. So d by dt of this thing, magnitude wise these two should be same. So when I remove modulus, it will be negative because I know omega is going to reduce and become 0. Then yeah, I think dt I brought it here. Omega dt is nothing but d theta according to the figure. Then yeah, then it's about integration. Yeah, so it's only about integration. You do the integration, you will be getting, so when theta was 0, initial situation, when theta was 0, omega is initial omega. When theta is pi by 2, omega is 0. When theta is 0, omega is initial omega. When theta is pi by 2, omega is 0. So when you solve for it, you will be getting the required answer. Then two blocks of metal with heat capacities. Okay, so I will be reading the question. Two blocks with metal heat capacities 3 and 6 are interconnected by a rod of length L and cross section area. I think this kind of question already came in your exam. So the temperature will be, let me say this temperature is high and this temperature is low. So what will happen? Heat will be flowing from here to here, and this temperature will keep changing, this temperature also will keep changing. So when I take some generalized situation, at any time when this temperature is T1 and this temperature is T2, in the later moment this temperature is going to become T1 minus mod dT1, this temperature is going to become T2 plus mod dT2. This is increment, this is decrement. So what is the rate of heat flow from here to here? That is Ka by L into temperature difference. Now what will happen because of this heat flow? This temperature will reduce and this temperature will increase. So ms delta T, but m into s is given here. So C1 delta T1 and C2 delta T2 magnitude wise. So when I remove the modulus, I will be getting negative because dT1 itself is negative quantity. So negative into negative will be positive, and C1 value is given, C2 value is given. So that's the only equation we have to write, but the issue is integration, and they are asking only T2 minus T1 minus T2. So what we can do is, I can find dT1 from here. dT1 from here is this Ka by L, it is a constant, so I am calling it as lambda. So dT1 is going to be minus lambda by 3 into T1 minus T2. Now similarly, if I equate these two, I will be getting this equation. I need to find T1 minus T2. So what I will be doing is, I will be subtracting these two equations. Then I will be getting, I just need to subtract. Then you can see, I can write the same thing like this, and you can see T1 minus T2, T1 minus T2 is coming into picture. So if you assume that is x, then you can integrate it much easily. Wait, where was that dt? Oh, man. Okay, dq was not this. This is dq by dt. dq by dt. So into dt should be there. So there is that time thing missing. So dt1 by dt, dt2 by dt. So dt will be going here. So you will be integrating it. Now the T1 minus T2 I am calling it as delta T. So when you integrate, you will be getting the result, and lambda value I am just substituting it back. Okay, so the next question goes like, a sphere of mass m falls symmetrically on a set of 3 hemispheres. So I mean 3 spheres. When you look from the top, there are 3 spheres. So one sphere is falling like this and hitting this. So when it is hitting, this sphere which is falling is stopping, and those 3 spheres are going along the ground. Hemispheres mass is m by 2. Anyway, so then they are asking the ratio. So the only thing you need to do is the geometry thing. Now there are 3 spheres, and if one more sphere is falling, when you join their centers, you are going to get regular tetrahedron. Now that's the idea. So you will be getting regular tetrahedron, and when you draw the normal, so that's a 3D figure, so I couldn't draw that. So you will be getting a regular tetrahedron, and you will be drawing the normal direction. Now that figure they are drawing here. So normal will be in this direction. Now, when you draw the actual figure, there will be 3 spheres and 1 sphere like this. Now the line joining the top sphere to this sphere, that is this line, and that length is going to be 2r. That length is going to be 2r. Then this length, so that's going to be equilateral triangle and stuff. So you can find that length is going to be 2/3 of the height of the equilateral triangle. So from there you can get this angle, sin theta, you can get cos theta, you can get tan theta, you can get. Now the thing is, on this sphere there will be 3 kinds of normals like this. From one from this sphere, one from this sphere, one from the other sphere. Now their normals, vertical component is going to give impulse, horizontal components are going to get cancelled. So normal cos theta, that is impulse cos theta, 3 times, because due to one sphere, second sphere, third sphere. So 3 times of impulse due to cos theta will be changing the momentum of this guy. Now on this guy, impulse horizontal component, that is j sin theta. J sin theta will be changing the momentum of this guy. Then I am taking the ratio of u by v. I am substituting the value tan theta. But they are asking what is the ratio of initial kinetic energy of, kinetic energy of this guy before hitting to kinetic energy of this guy after hitting. You can substitute the value and you can get the answer. So in this question they were saying, there is a syringe and like you are applying force like this, and this water is going out with some speed. What is the work done by you? So basically the syringe is going to come to rest eventually, so I am not bothered about its kinetic energy. What is happening? Water center of mass is here, so water will be going out. If I assume like water is spreading like this layer, then center of mass is going here, so there is increment in potential energy of the water. Now when syringe goes here, increment in potential energy of the syringe. Apart from that, whatever water is going out, it is having the speed too. So water will be having kinetic energy also. So from where all this energy came, it came at the expense of my work done. So my work done will be going as increment in potential energy of the water, increment in potential energy of the syringe, and increment in kinetic energy of the water. All values you can just substitute and you can get the answer. This kind of question we have already seen. See, they were saying positive charge with constant surface charge density is distributed over the surface of a thin ring, if internal radii R1 and R2. The center of non-conducting ball with radius R less than R1. The sphere is uniformly charged with positive density. At what values of sigma is the resulting field vector at points on the surface of the ball? Is 0. So basically at the surface of the ball, field is going to be in this direction. Field is going to be in this direction, and field due to ring at the surface of the ball will be in this direction, in this plane. So when will those two get cancelled? So basically you need to find field due to the sphere and field due to the ring, and you should equate them magnitude wise because they will be direction wise opposite. Now finding field due to the sphere is easy task. Finding field due to the ring thing is not an easy task, but we have already seen it somewhere. That was this question, it is there in the doubt section thing. Now if I want to find the field due to ring along the radial point, I will be taking some Gaussian surface and I will be finding the flux through that, but total charge enclosed is 0, so flux will be 0. From there I will be getting electric field at P will be given by electric field at Q into R by 2x, where R is the radius of this thing and x is the distance, right? So till here it's the same thing, but electric field at Q in this particular question is electric field because of the ring, so I substituted ring formula. But in that question we need to find electric field because of that thin ring thing by integration, then you need to substitute the value. Then you will be getting electric field at point P because of that ring thing. Then you should equate that to electric field due to the solid sphere. Now the solution given was clear. The idea is this idea. So instead of UQ, substitute that integrated thing from the solution. So actual potential energy change is going to be that thing, but generally we will be using mgh because G will be approximately constant. Now they were saying, so what can be the maximum height, so that it is going to be like the error is only 5%. So actual measured value minus like whatever approximate value we take by actual measured value. So this percentage when they are asking when it will be like maximum 5%. When you solve it, you will be getting h is 0.05 r. So yeah, that is 320 km. If h is less than 320 km, you can always use mgh because the error is going to be 5%. Okay, the question is clear. I mean, you can read the question by yourself. I'll be doing the options. Now you know one thing, if this speed is v, then this speed is going to be 2. If the speed is v, it will be having angular velocity omega. So v equals to r omega. At this point, it will be v plus r omega, which is 2v. So if this center speed is v, this speed will be 2v. But what they said in the question? They said in the question this speed is v, so this center speed is going to be v by 2. If this speed is v, the center speed is going to be v by 2 at any moment. Now they are pulling this one by x naught, so this one will move by x naught by 2. So when you leave it, when the extension is x, then this guy will be at a distance x by 2 from the mean position. When this velocity is v, this velocity will be v by 2. When this acceleration is a, this acceleration will be a by 2. So, and energy also will be conserved because it is pure rolling. So initial energy is this much, which will match with option B to P. That equals to kinetic energy of this guy plus potential energy of the spring plus kinetic energy of this guy. Kinetic energy of this guy will have two components, translational kinetic energy and rotational kinetic energy. So you will be getting half into 1 plus beta into its mass into its velocity square, velocity of center of mass square. This includes total translation plus rotational kinetic energy. So yeah, velocity of the center of the cylinder will be v by 2, and energy of the oscillating system is this one plus this, this one or this thing. Now when you modify it, you will be getting this thing. So energy can be this one or this one. This is at this extreme position, this is at any random position. Now when you differentiate it, you will be getting acceleration is proportional to x. So you can get the acceleration of the Planck as well as when you can see SHM form, so you can get the time period also, angular frequency also. So the next question is very straightforward question. In the first question they gave potential, they are asking to find electric field, substitute the values x, y and z. In the second question they have given charge as a function of time, so you can find current as a function of time. Current is going to become 0 at 1 second, so you need to find I square r dt from 0 to 1 second. Then milliammeter, which can measure 10 milliampere. If you want to make it measure 1 milliampere, you will be shunting something. So out of 1 milliampere, 10 milliampere will go into this thing, remaining will go into this thing. These two are parallel, so this I into R equals to this I into R. In the next case, electric field is along x-axis and there are two charges placed along x-axis at a separation 8 centimeter. Now you don't know where is positive charge, where is negative charge, so you don't know dipole moment will be this way or this way. If the dipole moment is this way, then you will be getting minus P into E. If the dipole moment is this way, then you will be getting plus P into E. So potential energy can be plus or minus P into E depending on the dipole direction. When you substitute the values, you will be getting the answer as 0.4, right? Thank you.